Good evening, ladies and gentlemen. Thank you for joining today's webinar by Eastman, Sustainable Plastics from Eastman Circular Recycling Technologies for Better India. Right now, our people are tackling the biggest problem we have ever faced, problem that faces all. Our goal is to transform tomorrow by revolutioning the materials that shape it today. This is a statement from Eastman, and we have presenter Chris from United States, Suman Basu from India, Mr. Prashant from India, Neelam from India. Now, Mr. Suman Basu will introduce the speaker, and from there we will go for.
Hello everyone, Namaskar, a warm welcome. Sustainability is no longer an add-on to the business, it is a business imperative. At Eastman, every insight leading to a breakthrough innovation is achieved through collaborations. We listen to our partners, our customers, and we try to collaborate with them, searching for a new material which could answer to the problems we are facing for the humankind as well as for the environment. Eastman in India presents roughly 33 years now, but then that's a physical presence for with our office and people here, but our materials are much popular even before that. So it's about 102 years now. Eastman have been offering very creative, innovative product and solutions that touch lives of the people every day. And we continue to evolve with the support of our customers, our stakeholders, our associates and partners. So I'm very excited to introduce our sustainability director, and the presentation will be ongoing on the sustainability offering that Eastman could offer. Basically, it's basically to understand how this molecular recycling technology which we have introduced that enables to bring back the plastics waste material which are destined for landfill or ocean waste pollutant or to an incinerator back into the material loop. And that same can be done several times repeatedly without any compromise on quality or any additional process requirement. I'm very excited again to introduce our sustainability director, Mr. Chris Layton, and he's a very recognized speaker on sustainability, and he has been with the Eastman last 25 years now in various roles and responsibility. Before I hand it over to Chris, I would like to talk about two of other panelists. One is Mr. Bhagavat Patil. Many of you know him. He's our technology colleague, and Mr. Neelam Prashant Ramteke, she's from our marketing support. And I myself, Suman Basu, I take care for all commercial activities for the plastics division in Eastman. So over to you, Chris, please. Go ahead.
Suman, Ginu, thank you. As I said, my name is Chris Layton. I'm the Sustainability Director for Eastman's Plastics Division, and happy to be here this afternoon to share with you a little bit about who we are and what we are doing to help create a circular economy for plastics. Before I begin, as Suman said, I have been with the company for about 25 years in a variety of roles, starting in manufacturing, moving into technology, but most of my time has been spent in commercial leadership roles. As Sustainability Director, I have the really cool job of getting to work across all the market segments that we serve, everything from houseware, small appliances, medical devices, electronic devices, and auto to general packaging, and help those teams bring to market solutions that are enabled by our two advanced recycling technologies. So again, happy to be here. So for those of you that don't know Eastman, we are a $10 billion global specialty materials company. And as Suman said, this year we will be 103 years old. We're headquartered here in the United States in Kingsport, Tennessee, but we have a team of more than 14,000 people located at manufacturing plants, research centers, and sales offices throughout the world, including several sales offices and service centers in India. While we might not be a household name, there's a good chance you use a product made with one of our materials, as we sell to customers in more than 100 countries across a wide variety of applications. Our mission is to improve the quality of life in a material way. And so as we thought about that mission, we thought about the next 100 years of our company, we realized as a society we were facing several challenges. First, how do you sustainably care for a world that's fast approaching 10 billion people? Secondly, most people would acknowledge or believe we have a plastic pollution problem. And lastly, our climate is changing, and with that comes a whole host of challenges. So we as a company have chosen to put our money where our values are and have been investing into what we refer to as molecular recycling technologies. You may hear people refer to them as advanced recycling or chemical recycling. We refer to them as molecular recycling because we think it represents what these technologies do. And as Suman said, they allow us to take hard to recycle waste plastics, break them down, and then be able to return those precious resources back into the economy. In short, we think these technologies have a critical role to play in helping create a circular economy for plastics, hence our investment. These technologies have allowed us and are play a critical role in us meeting the commitments we have made as a company. These technologies will help us achieve our climate goals of reducing our Scope 1, Scope 2 greenhouse gas emissions by a third by 2030 and ultimately allow us to achieve carbon neutrality by 2050. These technologies will allow us to recycle more than 250 million pounds of material by 2025, doubling that by 2030. And we compete on a global stage, which means that we need people with diverse perspectives, and those people need to feel included, empowered to bring their best to work every day. And so you see also a variety of goals that we have set for ourselves around caring for society and inclusion and diversity. Again, all enabled by or supported by our investment in these two advanced recycling technologies. So I mentioned earlier the global plastic pollution challenge. This slide puts that challenge into perspective. So every year as an industry, we generate more than 300 million metric tons of new plastic. If you subtract out what goes into durable applications, you still end up with more than 260 million metric tons of plastics that reaches the end of their lives every year. And the unfortunate reality that's highlighted in this slide is that less than 20% of those plastics gets collected and recycled. A vast majority ends up landfilled, incinerated, or even worse, leaked into the environment. And so when you think of these molecular recycling, these advanced recycling technologies, think of them as trying to tap into that 80% of plastics every year that does not get recycled today, and being able to tap into those waste streams and keep them in the economy versus having them landfilled, incinerated, or worse, leaked into the environment. As a specialty materials company, we believe in choosing the right material for the right application. And while there's a lot of pressure on plastics, I think the reality of a world without plastics just isn't realistic. Plastics are an essential material, and certainly over the past several years, via the pandemic throughout the world, people, I think, recognize the value of plastics in providing, and enabling safe drinking water, safe food, helping protect us in healthcare settings. Again, plastic's essential material, but we do have to do a better job of addressing the plastic pollution challenge, and hence our investment in these advanced recycling technologies. So before I dive into our technologies, I want to make sure everyone is grounded in the difference between mechanical recycling, what you and I would think of as recycling today, and these molecular or advanced recycling technologies. So in mechanical recycling, you typically start with a relatively homogeneous material. The best example is a clear water or soda bottle. Those materials are collected, chopped up, washed, and then remelted, usually with the addition of a virgin plastic, and molded back into a new article. Very simple, very energy efficient process, but ultimately, after so many cycles, those products need to be downcycled or likely disposed. Molecular recycling complements mechanical recycling in a couple different ways. First of all, as you can see here, it is able to recycle a much wider variety of materials. Those waste plastics are then broken down through chemical or thermal means into their basic building blocks. That allows you to purify those building blocks such that they're indistinguishable from the same building blocks today we produce on fossil feeds. Then they feed into our existing polymer, fiber, chemical lines, and we can produce a product with really no compromise in safety, quality, and performance. And you can potentially do that again and again. And so the two technologies need to be thought of as very much complementary to one another. If you can meet your safety, quality, performance goals with mechanical recycling, you should. And we need to do more of it. But it has its limits, and that's where molecular recycling can complement it. So since the fourth quarter of 2019, Eastman has been operating two forms of molecular recycling, what we call carbon renewal technology and polyester renewal technology. Between the two technologies, we can recycle somewhere in the neighborhood of 20 to 25,000 metric tons of plastic today. And it's a wide variety across the two technologies, everything from olefins to polyesters, polystyrene, et cetera. And as I'll show shortly, we're making significant investments in expanding our polyester renewal technology. Our investments are guided by a few key principles, and I won't read all of these, but I will touch upon a few of them. So first, and perhaps most importantly, our investments are made only in technologies that are creating true circularity, what we refer to as material-to-material molecular recycling. Many of these advanced recycling technologies have historically been used to create fuel, waste to energy or waste to fuel. While that certainly has a place on the waste hierarchy, we don't think that is recycling, not circular. So again, our investments are only in material-to-material recycling technologies. Secondly, we're only investing in these technologies if we can have a net lower greenhouse gas emissions, lower environmental impact than we would producing the products based on fossil feeds. In simplest terms, we don't want to trade off solving the plastic pollution challenge to add to the climate challenge. So it's very important as we evaluate these technologies and bring them to market that we're addressing both issues, not only the plastic pollution, but also the climate challenge. Third, and this is one we'll spend a little bit more time on later in the presentation, you need to think of these technologies as very much complementary to the existing mechanical recycling technologies. As I said, if you can meet your needs from a safety, quality, performance perspective using mechanical recycling, you should. Much less energy intensive, lower carbon footprint, but again, it has its limitations, and that's where these molecular recycling technologies come to play. Lastly is this idea of transparency. And so what we are doing, leveraging these technologies to recycle waste plastics is new. And so we as a company have felt it was very important to be transparent in what we're doing. One of the ways we choose to do that is by having our processes, audited and certified by an independent third party. In our case, that's International Sustainability and Carbon Certification, ISCC. ISCC is an internationally recognized standard for certifying sustainable materials. They're headquartered in Europe and have certified more than 400 or 4,000 companies across 100 countries throughout the world. And ISCC certification does a couple things. First of all, it allows our customers, our brand partners, to be able to make a claim with meaning. They're able to put recycled content in levels that are meaningful and will excite their customers and let their customers know they are doing the right thing and by purchasing a more sustainable product. Secondly, it gives those customers and brand partners comfort. They will know whatever claim they make, there is through ISCC a trail such that at the beginning of the process, an appropriate amount of waste plastic has been recycled at the beginning of that. And so as we've made these investments and have been operating for the past 2 years, we've really used these principles to guide us as we make choices about how best to leverage and bring to market solutions enabled by these molecular recycling technologies. So let me go into a little bit more about the technologies. And so as I said, the first technology is what we refer to as carbon renewal. In simplest terms, it's a form of gasification. So as you can see, carbon renewal is a pretty robust technology in terms of the types of waste plastic that it can handle. Polyesters, polyolefins, polystyrene, ABS, polycarbonate. So we take those waste plastics and through high temperature pressure, we're able to break those waste plastics down into the basic molecular building blocks of carbon, hydrogen, and oxygen in the form of syngas. Going back to that basic molecule allows us to purify that syngas such that it's indistinguishable from the same syngas today we produce on fossil feeds. And then we feed it into our existing manufacturing processes where we can produce a whole host of cellulosic-based plastics, that might go into applications like eyewear. We can produce fibers that go into textiles, like our Naya product, and a variety of other chemicals. And so not only are we realizing the benefit of eliminating or diverting those materials from a landfill or an incinerator, but as you can see on the far right side, starting with waste plastic eliminates many of the steps and the energy and emissions associated with traditional fossil-based manufacturing, such that we can get to that syngas with significantly lower greenhouse gas emissions, anywhere from 20 to 50% lower, depending on the type of waste plastic we're feeding, how far that waste plastic needs to come from the source of generation to our plant, and what, if any, pre-processing we need to do in order to feed it into our reactor. So a pretty good story, not only diverting materials from a landfill or incinerator, but also eliminating some steps in a traditional manufacturing process that allows us to produce those materials with lower greenhouse gas emissions. Polyester renewal technology, as the name implies, is focused on polyester-rich waste. So do not think of that clear water in soda bottle. That's not what we're targeting. Think of perhaps a colored shampoo bottle, a pot or a thermoformed pot or tray that might hold meats or fruits and vegetables in your grocery store. Think of textiles. Think of carpet. Polyester-rich materials that today, by and large, are landfilled or incinerated. So through our polyester renewal technology, we're able to take those waste plastics through today, what we refer to as a glycolysis process. Tomorrow will be a methanolysis process. We're able to break those polyesters down into their basic building blocks. In our case, that's dimethyl terephthalate, recycled DMT, and ethylene glycol, e.g., the basic building blocks of polyesters. We take the waste plastics, break them down into those monomers. Again, when you get to the monomers, that allows you to purify those monomers such they're indistinguishable from the same monomers that we produce today based on fossil feeds. And then we feed them into our existing polymer lines. And as you can see here, we produce a whole host of finished products. everything from products like Triton that go into more durable applications to materials like our Cristal, which go into cosmetics, and then ultimately PET that go into food and beverage, personal care, packaging. And again, like carbon renewal, because you are eliminating the several steps associated with producing these materials based on fossil feeds, you're using waste plastics to start. You're able to get to those finished product, or those intermediates in this case, with significantly lower greenhouse gas emissions, 20 to 30% lower. We have been fortunate, as we've operated over the past couple of years, to be partnered with and work with a variety of different brands. And so on this page, you can see many of the companies that have launched products using our Renew materials, leveraging these two molecular recycling technologies. I'm sure many of the names might be recognizable to you. All of these brands are leaders in their respective spaces, but more importantly, all of them recognize the value of producing their products using more sustainable materials, leveraging these technologies. They also recognize this is a way to grow their business. As you look at the products these companies have launched using our Renew materials, leveraging these technologies, you see that they are beginning to be able to grow their business, either capturing more share because they have a more sustainable offering, or maintaining share but able to achieve a higher price premium. So again, these companies, along with us, are helping to show the world what's possible, and applaud the courage and appreciate greatly their partnership as we've been on this journey for the past couple of years. So as I said, we are in the process of completing our facility, our new methanolysis unit in Kingsport. And when that is done, we will be recycling in the neighborhood of about 110,000 metric tons of waste annually by this time next year. And one question that people ask is, well, how much waste plastic is 110,000 metric tons? So assuming Wikipedia was accurate, I believe the Narendra Modi Stadium in India is the largest cricket stadium in India, and 110,000 metric tons of waste plastic would fill the stadium and then some. So a fairly large amount of waste plastic. It will not solve the plastic pollution problem on its own, but it will take a pretty meaningful step, and so we're excited about it. Perhaps a more tangible way of looking at what that 110,000 metric tons of waste plastic is, putting in perspective articles that you and I use every day. So 110,000 metric tons of plastic that was going to a landfill will be the equivalent of diverting 11 million water bottles, 790 million t-shirts, 7 billion shampoo bottles. So again, pretty significant, exciting numbers, a long way from solving the plastic pollution challenge on their own, but a meaningful first step. Even more importantly, and maybe less obvious, is, again, by starting with waste plastics, you can have a significant impact on climate. And so that 110,000 metric tons a year will allow us to reduce our greenhouse gas emissions by about 45,000 metric tons. That's the equivalent of taking 150 million miles of vehicle traffic off the road. Again, won't solve the plastic pollution or climate challenges that are on their own, but a significant step forward. So what I'd like to do next is dig a little bit deeper into this idea of how molecular recycling, these advanced recycling technologies, complement traditional mechanical recycling, because no single solution is going to solve those challenges. We need all those solutions to be brought to bear. So you can think of it in simple terms: molecular recycling complements mechanical recycling in three main ways. First of all, we can tap into waste streams that today, by and large, get landfilled, incinerated, or leached into the environment. Secondly, because you go back to those basic molecular building blocks, you can produce finished products that essentially have no compromise in safety, quality, and performance, essentially virgin quality with no trade-offs. And that allows you not only to provide recycled content into applications today where mechanical can't meet the needs, but it also, in streams like PET, allows us to replenish that stream with virgin quality and help increase the effectiveness of mechanical recycling. And then lastly, and quite simply, if consumer products companies are going to meet their voluntary commitments, meet the regulatory requirements that are beginning to be put in place in Europe and the US, we just need more supply of high quality recycled content, and these technologies have the ability to do that. So let's dig a little bit deeper into those. So one question we constantly get answered or asked is, how are you feeding these processes? And as I said, our focus is on harder to recycle polyesters. We are not trying to use these technologies to recycle a clear water and soda bottle. That's best done via mechanical means. So this slide sort of highlights some of the types of waste streams that we are currently procuring for our Kingsport asset and anticipate feeding our future assets. So at the top, you can see we're going into the existing waste management and recycling value chain, and we are buying their waste products, the purge materials between campaigns that they run, the fines that are generated, and even products like strapping, which are used once and then ultimately landfilled, are good feeds for these molecular recycling technologies. We are partnering with companies to essentially create new sources of polyester feedstocks, things like carpet and textiles. And then lastly, we're working with various partnerships, both in Europe and the US, to get more stuff recycled in the simplest terms. The unfortunate reality is, as I said earlier, less than 20% of the plastic that reaches the end of its life every year actually gets recycled. We need more of that plastic to be recycled versus creating and adding to it with additional virgin. So as I said, a couple examples of where we're doing this. In the United States, every year we generate about 3 billion pounds of carpet that ends up in a landfill. We have a partnership with a company called Circular Polymers, who collects that carpet and is able to, in a sense, disassemble it, take the nylon for an end use, the polypropylene for an end use, and they create for us a polyester-rich fiber, which we in turn can recycle using our molecular recycling technology. So taking a material that today takes up a lot of space in a landfill and being able to make a productive use of it. Another example, in Europe, we have a partnership with Interzero. Interzero is one of the largest recyclers in Germany and throughout Europe. And while they recycle a lot of plastics, during the course of their process, they generate a lot of materials today that they cannot mechanically, olefins, which they're able to send to OMV for pyrolysis, polyester materials, which they're able to send to us for recycling. So again, a good example of how a company like Interzero, a mechanical recycler, can work together with folks like us and OMV and complement one another such that we get more of those resources that get into the recycling and waste management value chain and keep them in the economy versus going to a landfill or an incinerator. And lastly, and this is the idea of investing to create more materials or get more materials collected. We are part of the PACT coalition in the United States that's targeting small format cosmetics, jars and bottles to get those things collected. Today, they would end up right in the trash can. We are working with the Recycling Partnerships PET coalition to get colored bottles, thermoform trays and tubs and pots collected. Again, materials today that by and large do not get into a recycle bin and go right to the landfill in the US. So the second way that I mentioned that molecular recycling complements mechanical recycling is this idea of providing virgin quality, being able to produce finished products with no compromise in safety, quality, and performance. So a few weeks ago, the European consultancy Systemic issued a white paper that really talked about this particular issue. And so in Europe today, even though PET is one of the most highly recycled materials in the region, more than 75% of what gets put onto the market ends up incinerated or landfilled. And what the Systemic white paper kind of highlights is the ability or the opportunity to get more of that material recycled by leveraging both technologies, not only mechanical recycling, but chemical or molecular recycling. And this very busy slide, I apologize for it, sort of highlights that. So on the left-hand side, you can see if you start with a relatively homogeneous feedstock, something like a clear bottle, it allows you via mechanical recycling to be able to serve a lot of different end markets. You can turn it back into bottles, or you can make thermoform trays, it can go into polyester fabrics and or other types of packaging. When you move to the right, you can begin to see that once the feedstocks move beyond just a clear bottle, it becomes a lot more problematic for mechanical recycling. In short, there's no real means via mechanical recycling to remove impurities. So once you begin to add trays or fabrics or other packaging into it, you can see you no longer are able to, via mechanical means alone, return those materials back to a food grade bottle or a food grade tray. You end up having to maybe downcycle them into textiles, into other forms of non-contact sensitive packaging. And then skipping to the right, you can see that molecular or chemical recycling has the ability to handle a wide variety of different feedstocks. And because you take those feedstocks back to the basic building block, you're able to purify them, and that allows you then to serve a wider variety of end markets, including contact-sensitive things like food packaging, medical packaging, et cetera. So again, this idea of molecular recycling complementing mechanical recycling by being able to provide, virgin quality material. So a couple examples of where that's put into life. So the very first companies that launched products leveraging our two materials were Camelback and Nalgene. And so not surprisingly, right, these are brands that are producing products where they cannot compromise in the safety or the quality of those materials. And so these bottles need to be durable. They need to be able to withstand repeated washings. And again, mechanical recycling can accomplish some of that, but really you need these molecular technologies to be able to do that fully. Another example is our partnership with Procter & Gamble. Today, a key part of the herbal essences story is those bright natural colors that are part of the brand that is herbal essences. Today, that bottle probably would not be recycled in any meaningful way. Through these molecular recycling technologies, we're able to take that green or purple or white or blue bottles and recycle them and return them to Procter & Gamble into resins, which have the same performance as a virgin PET, and they're able to create circularity for these types of bottles. And quickly, when we look at our portfolio of packaging, you can see we are serving a variety of different markets through a variety of different products. Everything from, Triton, as I mentioned, it goes into reusable, refillable, PET into personal care packaging. We have shrink labels that leverage these technologies, cosmetics packaging. So again, over the past 2 years, we have really been able to leverage these molecular recycling technologies to serve a wide variety of different applications, make a wide portfolio of products. So the last way that molecular recycling complements mechanical is this idea of just simply the world needs more high quality recycled content in order to meet the voluntary commitments many of our brand partners have made, as well as the emerging regulatory requirements. So, and we are putting our money where our values are. We are in the process of completing our methanolysis investment here in Kingsport. So that plant will be starting up later this summer. And when complete, it will increase the amount of waste plastic that we will recycle to about 110,000 metric tons. Last year, we made announcements of two additional investments. The first one was in January of last year, where we announced our intent to build a methanolysis unit in France. That investment will occur in two phases. The first phase will allow us to recycle around 110,000 metric tons of plastic. And then the second phase, which will follow shortly after it, will get us up, will be an additional roughly 100,000. So you'll have a total of 200,000 metric tons of waste plastic. Late last year, we announced our intent to make a second investment in the United States. Again, it will be done in a couple phases. The first one, 110,000 metric tons of additional material. When the second phase is complete, it will make a total greater than 200,000 metric tons. So both of those investments are in progress and targeting to be online by 2026. So I'll maybe a quick update on these. As I said, we are in the final stages of completing our investment in Tennessee and have a target startup date of later this summer, such that by the end of the year, we'll be producing finished product from that unit. The offtake is secured. Greater than 75% of the feedstock is secured. We are just now in the process of welding the last of the pipes, connecting the last of the wires, and beginning to start it up. So very, very exciting times to see that. On our second US plant, we completed or announced an offtake agreement with Pepsi, which will be the, if you will, anchor customer for that asset. We have a small number of sites that we're kind of finalizing and hope to be able to announce that in the first half of the year. And engineering work is underway. In Europe, with the France plant, we are in the engineering phase. The site was selected late last year, and it is a site in Normandy. And we continue to work with our brand partners to finalize offtake agreements. More than 50% of the feedstock is secured. So both projects, good progress on all of them. And this remainder of the year should be pretty exciting. As I mentioned before, we will start up the Kingsport methanolysis asset here in the summer and be producing finished product certainly by the end of the year. Second US plant, hope to be in a position where we can break ground by the end of the year. And the same thing with our France project. So combined, a lot of activity going on that we're very excited. But you can see at the bottom, you know, in addition to doing good, this is good business, right? We anticipate being able to leverage these technologies to generate, you know, more than 450 million of new EBIT for our business, you know, a return on capital of greater than 12%. So, you know, there is opportunity here. We're doing well, but then it's also a way to help grow our business. So again, very, very exciting. So I mentioned maybe in closing, just a quick picture of the methanolysis facility in Kingsport. So as you can see, largely construction complete, but we're in the process of welding the last of the pipes, connecting the last of the wires. So very exciting times to be able to see this finally coming to fruition. So I will kind of conclude here with a couple of points. You know, first and foremost, these molecular recycling technologies are going to be just part of the solution. They are no magic wand or silver bullet. No single solution is going to address those big challenges. We need a bunch of innovation. We need a bunch of solutions to be brought forward. Molecular cycling complements what we can do today with traditional mechanical recycling. We need both technologies. We need reduce, reuse technologies, as I said. And lastly, we're putting our money where our values are and are excited about these investments, but we are certainly not doing this alone. As I've shown throughout the presentation, we are working with a variety of different partners who are willing to take a risk, willing to try to show the world what's possible and try to do the right thing. And we'll continue to look for partners and look forward to continuing to innovate and collaborate that. And so with that, I'd like to thank again Ginu and Modern Plastics for providing us the opportunity to share a little bit about what we're doing and a little bit about our molecular recycling technologies. And with that, I'll turn it over to Suman, Ginu, and open it up for questions.
Thank you, Chris, for joining us. And it was a very wonderful, informative, and interesting presentation we could able to hear. There are many questions coming in, and I think we can read out the questions for you. Like, are you providing traceability of other data points apart from sustainability credits, such as CO2 emissions, water usage, sourcing information, etc.? Suman or Chris, anybody can answer it?
Yeah, so if I followed the question correctly, it was about traceability, correct, of products. So through ISCC, we will have a certificate from each waste plastic source that we have. So at the source of generation of that waste plastic, we will know kind of that it is indeed a waste, the type of waste it is, the quantity, and that will then feed into our process. And as we move it through the depolymerization process and finished product, we will be able to trace that waste plastic from the beginning of the process to the end, the finished product, again, to be able to provide transparency to our customers. With regards to emissions, that information is available as well. If you go out to our website, you can see our life cycle analysis reports on both our carbon renewal and polyester renewal technology. And of course, as we work with individual customers, we're able to provide more details around the specific products that we're providing them.
Very, very good. Thank you. And today, there are so many questions coming in. Is your Renew series available in India to buy locally? Maybe I can go to Suman.
Yeah. If anyone is interested to buy any or renew a version, it is commercial now, so anybody can buy in India. The thing is, like, our heritage grades are available locally through distributors, but right now all the renew range is offered directly from Eastman, USA. Soon after, when we will be having our next methanolysis plant operational, so we will be able to supply and educate and support our distributor to be with us together, like they are doing in heritage product. They will be doing that same thing in renew versions as well.
Connected, one more question. Is there a facility also being planned in India for recycling PET? How do you look forward to India as a consumption of recycled plastics or as a source for plastics waste?
So far, yeah, we don't have any plan to put a recycling plant in India. Reason might be a couple of carbon efficiency part, because all our assets are located in US. So taking the waste material from here to in US might not be carbon efficient. I still pass it on to Chris to have a better overview on this.
Yeah, so we have opportunities where we've looked at replicating what we're doing in the US and Europe in Asia, but we don't have an active project doing that. And as Suman said, a majority of the waste for feeding the US and as well as Europe plants are collected and generated within region. We are exploring opportunities to basically import waste from all over the world, essentially. But as Suman said, we've adhered to that principle of making investments, making choices such that we end up with a lower greenhouse gas emissions. And quite honestly, that is what has been a limitation as we looked at importing waste streams from Asia into the US, for example, is that the emissions associated with that transportation from, Southeast Asia or China or India has been a limitation. Not every example is like that, but it is certainly a consideration that we've said we have passed on opportunities because we couldn't do it with a lower greenhouse gas emissions.
There is one more question, like who are you partnering with to focus your vision to reach our 100% sustainable planet?
Yes, Chris, I think you can take it. I mean, we have covered this actually, InterZero and a couple of other names already. Chris has mentioned that. I mean, it's a collaborative approach together, and then we have been already partnering with a couple of other different organizations. Chris, over to you. I think you can better explain on this. Yeah.
So one of the learnings we've had is securing waste plastic feedstock is very different than securing our traditional feedstocks. So polyesters, as most people know, one of the key building blocks is paraxylene. Well, there is a finite small number of paraxylene suppliers in the world, and one paraxylene looks a lot like the other paraxylene, and so we may have a handful of them. That is not the case with waste plastic. We have more than 1,000 streams of waste plastic in our hopper. Close to or more than 100 different suppliers. We anticipate the same thing. So really much different capability to secure feedstock, a much more fragmented examples. And like I said, some of the best examples are companies like Circular Polymers on carpet, InterZero with oversorted waste in Europe, and the list goes on.
Yeah. Is the recycled PET product traceable? If yes, what is the procedure?
So to make sure it's clear, in terms of traceable, as I answered earlier around ISCC, so we are able to kind of trace the recycled content from the source of generation through our manufacturing process, through the finished product and on the line. You will not be able to tell a recycled carbon molecule in our finished product. You won't be able to detect it differently than a virgin carbon, if that is the root of the question, right? That is, I guess, part of the beauty of the way these technologies work, as well as part of the challenge, is to be able to provide that transparency, because again, that when we break that waste plastic down, that DMT molecule is indistinguishable from the same DMT molecule that we produce today based on fossil feeds. You won't be able to tell the two apart.
If there are so many questions coming in again. How does the cost economics of molecular recycling compare with the mechanical recycling?
Yeah, sure. So, obviously in a forum like this, I can't get into the details of pricing, but I will say this: we are, as I shared during the presentation, we are competitive. We've been in the market for two years, and we are able to compete effectively, create value for our customers. So in simplest terms, the way this works economically is we are putting more energy, more effort into converting the waste plastics versus a mechanical recycler, but we are able to use feedstocks that today basically have little to no value. So if you think about, you know, a finished price and parity with mechanical recycling, our conversion costs, the energy that we put into our process is greater than mechanical, but we're able to leverage a feedstock that is significantly lower value, i.e. lower cost than them. And so we're able to get to a, you know, finished price that is competitive, right? And we try, you know, we do our best to capture the value of that. We have a variety of different pricing mechanisms, some cost plus, some, you know, RPET plus premiums. We have value-based pricing. So we're looking forward to this. This is going to be a key part of how we grow our business. And over the past couple of years, I think we've demonstrated that you know, companies can be profitable doing this.
What are the products anticipated from molecular recycling, and what is tolerance value of mechanical properties of these products? And also, are you sourcing waste plastics from India?
Yeah, so in terms of finished product quality, you will see no difference versus the heritage version. So the specifications, for example, for a Triton Renew product will be no different than a heritage Triton product. Same thing with our Cristal product lines that go into cosmetics, the PET. There will be no difference in safety, quality, performance of those materials. And then the second part of your question of sourcing from India, again, today we are not sourcing any waste plastic from India. And again, the primary reason is there's more than enough, unfortunately, there is more than enough waste plastic generated in the US and in Europe to fill the plants. And then secondly, we are very sensitive to the emissions associated with bringing materials from India or elsewhere in Asia. And so we've just not had the need for it.
There are so many questions I'm going to read out, but if anybody have more questions, if you don't answer the questions, you can contact the details given on the screen. In India, you have Mr. Suman, and in US, you can send your questions to Chris, and they will be happy to help you. There are some more questions I would like to read out is, can you compare with ABS with this material, like mechanical and tensile strength? And what about ultrasonic welding bonding with PMMA material?
So Ginu, can you please repeat the question? I'm not sure I fully understood it.
Can you compare with ABS with this material, like mechanical and tensile strength?
Yeah, so we do have products, and Suman, please jump in if you have additional comments. So we do have products that compete or are an alternative to ABS. Again, what we'd like to think is our value proposition versus ABS is this idea of creating circularity. ABS is mechanically recycled, for sure. Like I mentioned, like other plastics, there is a limit to how much mechanical recycling of ABS that you can do. Generally, you're sacrificing some mechanical properties, you're certainly sacrificing color. Again, when you're leveraging these molecular recycling technologies, you're producing a finished product that has essentially no different from the virgin product. And so if it's important to have higher levels of recycled content,
Yes.
Not willing to sacrifice safety, quality, or performance, that's where I think we feel like we can differentiate ourselves versus mechanical. Suman, I don't know if you have.
Yes, perfect. And we can discuss on on a case specific, like what exactly ABS is value is being added to this particular product, and we have almost all the competitive range to have similar or even better properties with our copolyester range. Besides the carbon footprint, that's more important. Like why we are here is basically to discuss, even if you're having the same system, you're probably using one of our copolyesters, heritage copolyester. You need not to go for any single change with your system. You need not to look for additional certification, which probably you are already enjoying with the heritage one. You're going to get the similar certifications and similar properties and look like a like product. I mean, repeatedly with a lesser carbon footprint. So that's the advantage actually. We can take it as, I mean, as a case basis. If you want, definitely contact us. We'll be get in touch with you.
Connected, one more question. What are the applications of your heritage products and the market focused in India? I think someone can.
Yes, primarily heritage products which you are selling basically for segments like durable, medical, cosmetics, diversified, like heavy gauge sheets and similar applications, where our heritage products are gaining much popularity. Besides our cellulosic, which is actually a most century-old product, and it's basically going for the spectacle frame application primarily. But then there are some conventional applications like tool handles, and there could be a multiple applications, like because it goes through the compounding process, and then uh, multiple applications could be thought of.
Yeah, there is one more question. Like, is there any symbol or like for virgin PET, there is a symbol one. Something, is there a similar number or something for recycled PET applied products?
Yes, whatever recycled PET material we are offering can have number one universal recycle symbol.
Another question is, what about ultrasonic welding bonding with the PMMA material?
We'll take this question aside when our technical colleague Bhagwat will answer this. Great. Any more question? You can go to the next.
Next one is, what plasticizer are made from recycled PET? Chris?
Yeah, so we do have plasticizers in our portfolio that are derived from DMT. Today the focus of our the recycling technologies has been on the plastics part of the portfolio. That's probably something in the future.
Yeah. One more question is, during converting the plastic waste to molecular level, is there any waste gas emission?
Yeah, absolutely. So in general, the processes, both carbon renewal and polyester renewal, are relatively high yield. And what I mean by high yield is 90% plus or minus of the material that comes in is created in output products, so fairly high yield. But we do generate some waste. In our plant in the United States, we're able to handle that waste. There's some part that's maybe consumed as fuel for the process. There's some material that ends up in our wastewater treatment plant. Some material ends up having to be landfilled, but it's a single-digit percentage of that. Like I said, the processes themselves are fairly high yield, 90% plus or minus, depending on the type of plastic.
Yeah. Is there any more questions? You can send your questions. It can be answered by any one of them from Eastman Group. And I'm sure that it is going to be a solution for all the problems in the coming future. Now, this is the time for vote of thanks. Especially, we thank Chris for joining us too early morning for you. Thank you so much for spending time with India on changing the thinking of adding more insight on the thinking of sustainability. And I'm sure that it is going to be a change path for many processors, especially thank you, Suman,
Thank you.
then Bhagavat, Neelam, and Team Modern Plastics for everything. And special thanks to the audience who joined us.
Appreciate.
And we are offering all the participants a free digital copy of Modern Plastics India magazine from the website www.modernplasticsindia.com. And if you or any of your friends miss this presentation, you can get it from Team Eastman, and you can have more information. And also, this webinar will be available for watching on modernplasticsindia.com and Modern Plastics TV for coming time. And we wish you all the best and a better planet by using sustainable products. Thank you so much for joining us. All the best.
Much appreciated, and thank you, Chris, thank
Yep.
you, Modern
Thank you.
Plastics.